I'm working on my new Matzilla Ultra 4 chassis, and I wanted to take this opportunity to go over building custom links. Now, custom links doesn't have to be for a full new chassis. It can be simply for wanting to extend the wheelbase on your SCX-10 to fit a new body or something like that. So this is really a video that's more for beginners or intermediate level crawlers and RCers, and less for the super experienced type of guys. But I wanted to take this opportunity to get into one of those very basics of getting into a custom crawler of some sort. I'm going to go over 3 different methods of constructing links today. Now, I'm going to make a couple of assumptions. First of all, I'm going to assume that you're using a Revo rod end. This is the rod end that I would suggest you use. It's about the strongest, and it's kind of the go-to rod end for RC crawlers. I'll post the part number for this rod end in the video description. I'm also going to assume that you're able to calculate the length of the links you need. I understand this can be a little bit difficult at times, but just a basic overview is you'll want to set your axle approximately where you think it's going to go, and then get your chassis set. From there, you'll want to measure from where the link mounts at the axle to where the link mounts at the skid plate. And then you'll want to take your rod end and subtract the distance from the center of the rod end to approximately where the link will stop inside of the rod end. And then that is the length of the actual link you'll need. So that's a broad overview, and I understand that those can be a little bit tricky at times to handle, but I'm sure you can get it, and it just takes sometimes a little patience and a little extra tuning. I'm going to go over 3 different types of link fabrication, and just as a quick overview before we get into the actual demonstration of them is, first of all, I'm going to go over a sleeved all-thread method, which just requires some all-thread and whatever type of material you plan to sleeve it with. The second version I'm going to go over is the aluminum rod cut to length, drilled and tapped for the set screws at each end, similar to the aluminum links that would come in an axial type kit. Lastly, I'm going to demonstrate a one-piece link, which is where you cut it to length and then you'll actually turn down the link itself and then run a die down it to create a one-piece link. So we're going to go over them from least difficult to most difficult. So we're going to take this and we're going to move into the shop, and we're going to get actually into the fabrication of each of these types of links. Alright, so we moved into the shop, and I'm going to start getting into the fabrication of the simplest type of link, and that is the all-thread using a sleeved rod over it. Now this is the easiest to construct, requiring just only a Dremel tool, but it's not the strongest of the 3 that I'm going to show you. However, this type will work well for most people's use. Unless you get into the higher power or much heavier trucks, this type of link will probably take care of you just fine. And you know what? If it bends, you know how to make a new one. So absolutely a great way to make links. If you're a new guy and you really want to get into making your own trucks, this is the first step that you really need to learn. Now our first step to this is going to be cutting it to the proper length. I made myself a small template here out of a small piece of wire. You can just simply use a ruler. I'm going to take it and match it up to the end of my all-thread. I'm going to mark my cut line with a Sharpie, and really the only tool you'll need for this entire method is a Dremel, and I would suggest some safety glasses because Alright, so that is the base of our link. Now, just a little tip for you guys. Threading this into all-thread can be kind of a pain. So one suggestion that I give you is take this and bevel the edge of it with your cutoff wheel on your Dremel disc. This will make it much, much easier to start in your Revo rod end. And one other thing is, or a little tip, is take and bevel a small piece, just a small scrap piece, and if you have a cordless drill or a drill at all, take that piece and chuck it into your drill, and then use that to kind of pre-thread your Revo rod ends. It makes screwing them in so much easier. And if you have the tools available, you can actually take and chuck up an 8/32 tap and run it down the Revo rod ends themselves. If you're going to do this, what I suggest is taking your hex driver and putting it through the Revo rod end to help support it so it doesn't rip it out of your hand. So now we have a nice beveled edge on that, and it will make it much easier to start. So I already had one of these links made, and I just made another. One thing you want to make sure that you do is compare the length. Line up one side and make sure that the other side is exactly the same. And you can adjust the length by just threading or unthreading the rod ends a little bit more. Doesn't take much with 8/32 to adjust them to just the right amount. So get them as close as you can, and then you're ready to work on sleeving them. For sleeving your rod ends, you can use whatever material you like best. If I'm doing the sleeved all thread method, I like to use stainless. Stainless is a little bit stronger, and therefore if I'm going to use this method, which isn't necessarily the strongest method, I like to use the strongest materials I have available. This is also by K&S. This is 1/4 inch stainless steel tubing, and what it will do is it will slide nicely over our all thread, and then you'll be able to tighten the rod ends down on each side. Now we've made the link already, so all we have to do is measure the distance between the two shoulders of the rod ends and then cut our tubing to length. I'm going to simply match the tubing up on one side, get my Sharpie, and mark the other side for the cut. So once we have our tubing marked, I'm going to grab our Dremel again and get to cutting. Make sure that you're still wearing your safety glasses. Once you've cut your tubing to length, check to make sure that the exact same length. That way when you tighten your rod ends down onto the tubing, your links end up the exact same length as well. Now we've installed our tubing, and we have two links that look good and should be pretty strong. Now we're going to get into the second method of constructing links. This does require a few more tools and just a little bit more experience. What I've got here is some 1/4 inch aluminum rod. You can buy this also at Home Depot, hardware store, some hobby shops, and things like that. Now for this method, what we're going to do is we're going to cut this piece to length, and this length is going to be the distance between the rod ends. Be the same distance as it would be for just the steel tubing on this. After we cut this to length, we're going to drill the end and then run a tap down it, and then use an 8/32 set screw to go into the aluminum, and then our rod end will screw onto that. Now for this method, one thing that you really should pay attention to is trying to get your cut as flat and perpendicular to the rod surface as possible. This just makes it easier to run your drill and tap down it when you're going to put the set screws in. For this method, trying to keep this as simple as possible, I'm just going to use my Dremel to cut this. I have access here in the shop to things like the bandsaw and the lathe, but I want to try and do this as if I was the beginner RCer. One tip for you guys is that if you couldn't see while I was cutting that, I was spinning the rod. Now that was so that I could get in there without having to try and angle my Dremel, and that was to get the most flat cut as I possibly could with simply using a Dremel and doing this by hand. Now that we've got this rod cut, one thing I would suggest is trying to sand the end smooth. You can do that with any type of sandpaper you have. Aluminum is very easy to sand. The next step in this is actually to drill and tap these links for the set screw. Now this does require a drill and tap set, but these are pretty cheap, and you can also pick these up at your local hardware store. So for this step, I am going to use a vise because I have it here. You can use a pair of pliers or anything like that to hold them, but if you have access to it, try and use something like this. It's a little bit safer. You want to try and minimize any risk of running a drill bit into your hand or anything like that. You want to drill as close to the center as possible and as parallel to the link as you can. I've got the drill bit for the 8/32 tap chucked up in my cordless drill here. If you have access to something like a drill press or things like that, it'll make it that much easier. But again, trying to stay as basic as we can. Alright, now that we have the link drilled, we're going to take our 8/32 tap and put it into our tap holder. If you don't have a tap holder, you can use a pair of pliers or things like that, but if you can, I would really suggest buying a cheap tap holder. They're not very much money and they're a big help when you're doing this type of thing. So at this point, we've drilled our link, ran the tap down it, and now it's time to install the set screw. This set screw is an 8/32, 3/4 of an inch long. Thread the set screw down into the rod and tighten it enough to ensure that only the amount of thread that's adequate to install into the Revo rod end is exposed. So we've installed our Revo rod end, and now we have a link that is a little bit stronger than the sleeved method, but takes a little bit more work. I will say that this is my least favorite method of constructing links though. It's time consuming, drilling always seems to come a little off center, and in general, it's just not the way that I prefer to do things. So for that reason, I'm not going to construct the other side of this one, and instead I'm going to move right along to the last method. So this is going to be the last method of constructing links that I'm going to show. This is the most difficult, but in my opinion, the strongest method of constructing links. However, it does require some specialty tools, but it might give you an idea of how some things are built, or maybe down the road, if you get really into building custom RCs, something that you'll shoot for yourself when you're looking for your ideal tool set for your own shop. We're going to start out with this piece of 3/16 stainless rod. Now, we're going to start out similar to how we did with the all thread method by cutting the piece the total length that we'll need, including the threaded ends. Since this method requires some other specialty tools anyway, I'm going to take this over to the bandsaw and cut these to the length that I need, and then we'll move on to the next step. Now, for the one piece method, you do need access to a lathe. There may be another way that you can turn down the end of these to the proper diameter and have them nice and concentric still, but for the most part, this is going to be the way that you need to do this type of thing. If you don't have access to a lathe, that's why this method is not really for a beginner RCer. So right now I'm going to take and turn down the outside threaded area of the stainless steel rod so that I can prepare it to run the die down it to create the threads. For this, I need to turn that rod down to the major OD of an 8/32 thread. So I'll use my calipers to measure that first. And then I will use this to check the diameter as I turn these down. After running the die down the link, we've come up with a one-piece link that has the threads cut right into the material that the entire link is made out of. This is really the strongest type of link that you can get, and depending on the material you get, you can vary the strength even further. This is the type of link that I typically like to use when I'm building a truck. However, when I'm mocking up a truck or anything like that, I still like to use the all thread method. I might not sleeve it, but I might mock the entire truck up with just raw all thread links with no sleeving. That allows me to test the articulation and movement of the suspension throughout its entire travel before I actually get the exact links that I want to run at the end. Alright, so we covered the 3 ways to make custom links. Now, some methods are obviously much easier than others. Some require quite a bit of specialty tools and equipment, but no matter what, hopefully one of these ways works for you and taught you a little bit about different ways that you can build these types of things. Custom links don't have to be a big pain or a big expense. You can do them at home with some pretty simple tools if you want to get your hands dirty. So hopefully you guys can jump right in and make some of your own. Hopefully this video helped, and maybe some of my others will as well. Go check out my channel and check out my monthly updates. I run giveaways every month to help give back a little bit to the subscribers that help build this channel. So, alright guys, that'll do it for this one. Follow along as I progress further in this Matt Zilla build, along with many of my other builds. Check out my channel. Tell a friend. I appreciate all the support, and we'll see you guys later.